Chapter 5, we're going to focus on adding and subtracting fractions. So first up, we have some basic examples of addition and subtraction. The key thing to remember is that the denominator doesn't change. So 1/5 plus 3/5 is 4/5. We just add the numerators. 3/8 plus 1/8 is 4/8. And that simplifies. I can divide both of those by 4 into 1/2. 4/7 plus 3/7 is 7/7. 7/7 is the whole number 1. Anything divided by itself is 1. And 3/4 minus 2/4, 3 minus 2 is 1/4 or 1/4. So when the denominator is the same, we just add the tops or subtract the tops and then simplify our answer. If, however, the fractions don't have common denominators, they have unlike denominators, we need to find the least common denominator in order to do our addition and subtraction. So the way I like to do that myself, I'm going to look at my two denominators. In this first example, I have 6 and 9. And I'm going to say, okay, self, does 6 divide into 9? And the answer is no. 6 times nothing equals 9. What is the next multiple of 9? I'm working off of the biggest number. And the next multiple of 9 is 18. Does 6 go into 18? Yes, it does. 6 times 3 is 18. That means 18 is the least common denominator. So we're going to change both of these fractions to say that they're going to be over 18. Now our first fraction. How does 6 become 18? Multiplication by 3. So we do the same thing to the 5 on top. 5 times 3 is 15. 15 over 18 and 5 over 6 are the exact same thing, just different forms. How does 9 become 18 on the second fraction? Well, by doubling. 9 times 2 is 18. So we'll do that times 2 to the 4 on top. That's 8. 8/18 and 4/9 are the same thing. Now these fractions have a common denominator, we can work with it. 15 plus 8 is 23/18. That's an improper fraction, and you're not allowed to give me improper answers. So, last chapter I showed you how to do this conversion by division. But we can also just do it by reasoning it out. How many times can you take 18 away from 23? Well, you can take 18 out of 23. If you take an 18 away from 23, what's left? Well, 23 minus 18 is 5. So there would be 5 left. So the conversion from improper fraction to mixed number changes 23/18 to 1 and 5/18. Let's look at our next example, 7/12 minus 1/3. The bigger denominator is 12. Does 3 divide into 12? Yes, 3 times 4 is 12. That means 7/12 gets to stay part of the problem. However, our second fraction does need to change. So how does 3 become 12? Well, I just said we multiply by 4. So we do that to the numerator as well. 1 times 4 is 4. Now I can subtract. 7 minus 4 is 3. 3 over 12 simplifies. I can divide both of those by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. The answer is 1/4, 1/4. Our next problem has 2/5 and 3/7. So 5 doesn't go into 7, or 14, or 21, or 28. The common denominator here is 5 times 7. It's 35. So we have to change both of these into fractions that have 35 on the bottom. On the first fraction, to change 5 into 35, we have to multiply by 7. For the second fraction, we're multiplying by 5. So what does that do to our numerators? Well, 2 times 7 is 14. 3 times 5 is 15. Now we can add. 14 and 15 is 29. And 29 and 35 don't simplify. 29 is prime, actually. So the answer is 29/35. And my last example here, we have 4/5 minus 1/2. 2 does not go into 5, but 2 does go into 10. So we're going to change both of these to say over 10. How? Well, the first fraction, 5 becomes 10 by multiplication of 2. And for the second fraction, 2 becomes 10 by multiplication of 5. So, 4 times 2 for our first fraction becomes 8. And our second fraction, 1 times 5, becomes 5. Now we can subtract. 8 minus 5 is 3. And 3/10 does not simplify.